Welcome. Today we discuss a new chapter, circle, for different competitive exam. Let us discuss that this one ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This is called general equation of second degree. A circle, actually, it represents a second degree equation. Now, this general equation will represent a circle if a is equal to b, that is, coefficient of x square is equal to coefficient of y square, number 1. And number 2 is that h is equal to 0. That is, the product term x into y, this must be absent. And number 3, g square plus f square minus c must be positive. If in the general equation of second degree, these three happens together, a is equal to b, h is equal to 0, and this is positive, then it will represent a circle. Every circle must have a center and a radius. So if this is the equation of circle, that x square plus y square plus 2gx plus 2fy plus c is equal to 0. This is equation, second degree equation. It is a circle because of the fact that coefficient of x square and coefficient of y square are same, both 1. xy term is absent here. No xy term is present there. And if g square plus f square minus c is equal to positive, then it will represent a circle. Now, suppose this is a circle. For this circle, its center is minus g minus f. That is, coefficient of 2x with negative sign and coefficient of 2y with negative sign. This is equation, this is the coordinate of center of the circle, and its radius is root over of g square plus f square minus c. This is radius. And because we have taken that g square plus f square minus c is positive, so there is r is real and it is the actually radius of the circle. One more information, you know it. Suppose alpha beta is center of a circle and r is radius. In that case, x minus alpha whole square plus y minus beta whole square is equal to r square is the equation of the circle whose center is at alpha comma beta and radius is r. It is contrary, if we get an equation like that, it represents a circle and its center is at alpha beta, radius is r. Another information, for a circle, if two ends of a diameter of a circle is x1 y1 and x2 y2, this is a diameter passing through center. One end is this A and other end is B. Then equation of the circle is x minus x1 into x minus x2 is equal to 0. The next one is very important thing. Suppose this is a circle. Its center is considering and comparing with that alpha is equal to 0, beta is equal to 0. That is, it is a circle whose center is at origin 0, 0, radius is r. So this is a circle. Its parametric representation is x is equal to r cos alpha, r cos theta say, and y is equal to r sin theta. That is, any point on the circle x comma y can be expressed in terms of r cos theta comma r sin theta. That is only in terms of one single variable, which is theta. And for calculations, etc., taking parametric coordinate on a circle, this will be very helpful in terms of calculation. Similarly, for this circle, it is a circle whose center is at alpha beta and radius is r. In that case, its parametric coordinate is x is equal to alpha plus r cos theta and y is equal to beta plus r sin theta. Here you see alpha and beta are known quantities, r is known quantity. So once again, any point xy on the circle can be expressed only in terms of single variable theta. So next, suppose x minus alpha whole square, no, not that. Suppose x square plus y square plus 2gx plus 2fy plus c is equal to 0. This is a circle, and lx plus my plus c is equal to 0 is a straight line, like that. Say this is a circle and this is another one straight line. It may meet the circle like that, or it not meeting that, or it touches the circle. Three cases may happen. So a circle is given, so its center C can be obtained as minus g minus f. So its distance from the given straight line minus gl, for y put minus f, minus fm plus c by root over of l square plus m square. Suppose that distance is say k. I give one magnitude of, take one magnitude of that, because distance cannot be negative, and its radius of the circle is say r. If the distance k is greater than r, the straight line will not meet the circle. If k is less than r, k, if it is less than r, then it will meet the circle at two distinct points, this point and that point. And if k is equal to r, in that case k is equal to r, this straight line touches this circle. Base. Common chord of two circles. Suppose two circles are that and they meet. In that case, this is AB is the common chord of the two circles. So if they meet, means what I discussed here, under certain conditions they will meet. If they meet, in that case, equation of the common chord AB can be obtained from there. First, make the equation of the two circles such that coefficient of x square and y square of the both circles make same. In that case, suppose S1 is equal to 0 is a equation of the first circle, and S2 is equal to 0 equation of the second circle. Mind that in both cases coefficient of x square, obviously y square, must be same. In that case, S1 minus S2, simply subtracting these two, S1 minus S2 is equal to 0, it will be the equation of the common chord. Very easily we can obtain that. Next, now I discuss condition that two circles will touch. This condition, touch means they will touch two circles. Suppose this is a circle and that is another circle. Suppose they touch. In that case, center of the first circle, center of the second circle, and point of contact, they must lie on same straight line. Suppose it is C1, it is C2. Radius of the first circle is R1, radius of the second circle is R2. If from figure it is very clear that C1, C2 distance, that is distance between two centers, if it is equal to R1 plus R2, radius plus radius of the second circle, if C1, C2 is equal to sum of the radii, in that case they will touch externally. Consider this case. These two circles touch, but it is not externally like that. They touch internally at that point. In this case also, the centers C1, C2 and meeting point, they must lie on a same straight line. Number one. Number two, C1, C2, that distance, C1 to C2, that distance must be R1 minus R2. That is, R1 minus R2 means R1 difference R2, which suppose R1 is more than R2, in that case R1 minus R2. So, if the two circles such that distance between the centers is equal to difference of the radii, in that case they will touch internally. And in fact, C1, C2, that length, if it is next, okay, this I have already discussed. Next, sometimes we have to find the two circles are given this and that. We have to find their point of contact. Suppose by calculation we find that they touch externally like that. So to find the point of contact, this point. So point of contact is say a P point. This point is P. But in that case, it is very clear that point of contact P is the point of intersection of C1 first center and C2. They meet, I mean C1 C2 divides the point of contact P in the ratio R1 is to R2 internally. Similarly, for this case, point of contact is P. Therefore, C1, we know C1, it is center of the first circle. C2, the center of the second circle, like that. Here also, C1 is center of the first circle, C2 is center of the second circle, and they meet internally. In that case, point of contact P can be obtained in the ratio that C1, C2 meet P externally in the ratio R1 is to R2. Another very important information, one circle and it's normal. For any circle, normal at any point must pass through the center of the circle. So this is the very easy way to identify whether a straight line is normal to a circle or not. Means if it passes through the center of the circle, then only, and it is sufficiently, we can say that the straight line is normal to the straight circle. Next, suppose equation, this is a circle, this is another circle. Obviously, they meet at most at 2 points. Suppose they meet A and B. This point A, that point is B. So through these points A and B, we can draw infinite number of circles. So general equation of circle passing through two given equation is that, suppose equation of the first circle is S1 is equal to 0 and equation of the second circle is S2 is equal to 0. Then equation of the general equation of the circle passing through meeting point of these two circles A and B is S1 plus K times S2 is equal to 0, where K is an unknown constant to be determined from another given condition. From this condition, K can be obtained. That type is also very important. Same is the case. Equation of, suppose one equation of circle is given, one equation of straight line is given. In general, they meet at 2 points. So equation of circle passing through these 2 points, meeting point of straight line and circle, is same as that. Suppose S1 is equal to 0 is a circle and L is equal to 0 is a straight line. It is equal to S or S1 plus K times L is equal to 0. K is an unknown constant which can be determined from another given condition. Base. Now we take few problems. A circle, first problem, a circle touch y-axis at 0, 3 and makes intercept of 8 units from x-axis. Find its equation. The given information is that a circle, for to get an equation of circle, 3 conditions must be given. Number 1, here it touches y-axis. It touches y-axis at the point 0, 3 means it passes through 0, 3, 2, and it makes an intercept of 8 units from x-axis. Suppose this is a circle. It touches y-axis at the point 0, 3 and it makes an intercept of 8 units from x-axis. Suppose this is center of the circle. We know that a circle, this is a tangent to the circle, y-axis, it touches y-axis. At the point of contact, if we draw perpendicular to the tangent, it must pass through the center of the circle, Number 1, suppose this is C, center. So, from center, if we draw perpendicular on any chord of it, then it will meet the chord at their midpoint. From center, perpendicular is drawn to any chord, so that perpendicular straight line will meet the chord at their midpoint. So, if it is chord is AB, then this is 4, etc. Now, very clear that this is 3 unit, this one. So this one is 3. Radius is, say, CB. Radius. From Pythagoras theorem, R square is equal to 3 square plus 4 square. So R is equal to 5. Radius is 5. So for that circle, we get radius as 5 units. If we find center, then very easily we can find the equation of the circle. Coordinate of center, C, you see, y coordinate is that, this, y coordinate is this, which is nothing but 3. So we get y coordinate. And for x coordinate, it is our x coordinate of C. X coordinate of C is that this length is equal to that length, which is nothing but the radius of the circle, which is 5. So its center is 5, 3 and radius is 5. So its equation is x minus alpha whole square plus y minus beta whole square is equal to r square, that is 5 square. That is x square minus 10x plus 25 plus y square minus 6y plus 9 is equal to 25. So this cancels. So it is x square plus y square minus 10x minus 6y is the required equation. Oh, option is there, but I forgot to write the options. So this is the, I think, this is the third option. So this is equation of the circle. Next problem. A circle passes through A and B, 2 points A and B. If length AB is equal to, if AB is half of the diameter of the circle, that is half of the diameter means radius. So AB is R and its distance of AB from center is √6, then radius of the circle is options 2 √2, 4, 3 and 3 √2. As a given information, a circle passes through the point A and B. Suppose this point is A and that point is B. Given that the length AB, length of the chord AB, it is equal to half of the diameter. Half of the diameter means if this is diameter, it's half, that is radius. So this is radius. And if it is center, from center to the chord AB, its distance is given as √6. From center to chord AB, it is √6. Then find the radius of the circle. So from center, B is a point on the circle, circumference of the, so this must be radius. And from this to that, AB is your R. So this one, R by 2, half of that, because from center, perpendicular is drawn to the chord. So that point must be half of that, must divide AB equally into 2 parts. That is, this is equal to half of the whole thing, that is half of R. So this is R. Now from this triangle, we get by Pythagoras theorem, R square is equal to R by 2 whole square plus √6 whole square, 6. That is R square minus R square by 4 is equal to 6. That is 3 R square by 4 is equal to 6. So R square is equal to, this cancels with 2, 8. So R is equal to 2 √2. Radius of the circle is 2 √2, that is that. This one. Now let us take our next problem. Equation of two circles are x square plus y square plus 2x minus 2y plus 1 is equal to 0, and x square plus y square minus 2x minus 2y plus 1 is equal to 0. Then which one is true? Number 1, they do not intersect. Second option, touch. each other externally, touch each other internally, intersect at two distinct points. Now, this problem is very simple. Two circles are given. We have to examine whether these two circles meet at 2 points, touch externally, touch internally, or do not intersect. Achha, for that purpose, equation of the first circle is this. So its center C1 is equal to, it is simply x coordinate is coefficient of 2x with negative sign. Coefficient of 2x is 1, with negative sign means -1. And coefficient of 2y with negative sign is 1. This is y coordinate of the first circle. And its radius r1 is equal to root over of g square plus f square minus c, that is 1. C2. C2 is the center of the second circle. It is coefficient of 2x with negative sign, that is 1. Coefficient of 2y with negative sign, that is 1. And R2 is equal to root over of g square plus f square minus 1. Again it is 1. Now C1, C2, the distance between two centers. They will touch externally if C1, C2, distance between C1 and C2 is equal to sum of the radius. If they touch internally, we have seen that C1, C2 is equal to difference of their radius. First of all, I attempt for that, this and that. So C1, C2 is the distance between C1 and C2. It is 1 plus 1, 2 whole square plus 0, that is 2. C1, C2. Again, R1 plus R2 is equal to 1 plus 1 is equal to 2. So we get distance between C1 and C2 is equal to sum of their radius, that is 2. Therefore, they touch externally. So this is the correct option. Next. If 4 points 2k, 3k, number 1, 2, 0, 0, 3 and 0, 0 lie on a circle, then value of k. That problem was given in West Bengal Joint Entrance Examination in 2012. Here, the problem, I am discussing the problem. 4 points are given. Of them, these 3 points are in terms of known quantities, and this is in terms of k. If these 4 points are they lie on a circle, then what would be the value of this k? That is the problem. Very simple problem. Now, this you see the Here, the problem is it is 20 point. This is 03 point on y-axis. It is on x-axis, and this is 00. I am discussing about the 3 points. These 3 points, you see, one is 00, other is lying on x-axis 20, and other 03. Very clearly, this is a right angle triangle. So, in that right angle triangle, we get that this side is on semicircle. So this must be the radius of the circle. Sorry, this must be diameter of the circle. So this is diameter of the circle because this angle is 90 degree. So we get that diameter of two ends, one is this, other is that, x1, y1, x2, y2. So its equation can be obtained very easily. Formula is x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. That is, in that case, it is x minus 2 into x minus 0. I am not plus. Y minus y1, y minus 0 into y minus 3 is equal to 0. That is x square minus 2x plus y square minus 3y is equal to 0. This is equation of the circle. X square minus 2x, y square minus 3y is equal to 0. So this is equation of the circle passing through these 3 points, last 3 points. Now, given that these 4 points are concyclic, means they are lying on the same circle. So this point must lie on that circle. That is, this point must satisfy that. So that is 4k square 2k whole square minus 4k plus y square means 9k square minus 3 into y means 9k is equal to 0. That is 13k square, this and that, minus 13k is equal to 0. So we get k square minus k is equal to 0. So k is equal to 0 and 1. If k is equal to 0, this point is 0, 0, that is lying with that. So this is not correct answer. So answer is k is equal to 1, that is 2, 3. Oh, options are not given here. I have forgotten it. So 1, 1 is the k is equal to 1 is the correct answer. So today is up to that. Next day we will take many more problems of different joint entrance examination, IIT, West Bengal joint entrance, etc. Thank you.